is Algebra 1, Lesson 56. We're starting on page 228, and we're going to be talking about finite and infinite sets, membership in a set, and rearranging before graphing. Okay, so we'll start with some definitions. Finite means bounded and with limits. Infinite means unbounded and without limits. A finite set has a finite number of members, and we write it like this. Okay, so we have braces and the numbers in between. This is a finite set. No other members need apply for admission because this set is full. It will contain no other numbers. Okay, so now we'll do an infinite set. An infinite set has an infinite number of members. So we will write that like this. Okay, the ellipse on the end says that the list of members continues in this pattern with no end. So it just keeps going on and on and on. Okay, membership in a set. If we have these numbers, okay, so we have these numbers, and they are in a set. We're going to choose to designate this set as set B. So B equals a bracket, 0, 1, and 2. We say this as B is the set whose members are 0, 1, and 2. Note we only list each number once. If we say D is the set that includes so D is the set whose members are 0, 1, 2, 3, and 4. Now this set could contain any number of zeros or 2s or 4s. We don't know that, but we know that these are the only numbers that belong in the set. Okay? So here's an example. Represent the following numbers as being members of set K. 1, 0, 2, 1, 0, 5, 7, 4, 5, and 7. So we would write K is the set whose members are, and just for the sake of organizing things, I'm going to put these in numerical order. So I'm going to start with 0, and then there are 1s, and 2s, and 4s, and 5s, and 7s. Okay? Represent the following numbers as being members of set L. So L is the set whose members include negative 13, 0, 1, 7, 8, 15, and 42. We use this symbol, which means element of, to designate whether a number is or is not a member of a set. So this is an element of, this is not an element of. If we say 0 is an element of L, we know that in the set of L, one of the numbers is 0. Or we can say 23 is not a member of set L. It is not an element of set L. Okay, so here's an example. Given the sets A with the members 0, 1, 3, and 5, B with the members 0, 4, 6, and 7, and C with the members 1, 2, 3, 5, and 7, are the following statements true or false? 5 is an element of A. Well, here is A, and 5 is a member, so this would be true. 4 is a member of C. Here is C, 1, 2, 3, 4, 5. 1, 2, 3, 5, and 7. So 4 is not a member, so this one is false. 5 is not a member of B. Here's B, and 5 is not a member, so this would be true. Okay, given the sets L, which has members 0, 1, 2, and 3, M, which has members 5, 6, and 7, and N, which has members 0 and 1, are the following statements true or false? Is 6 an element of L? It is not. Is 0 an element of N? It is. Okay? I think you guys can handle that. Okay, let's go on to the next section. Rearranging before graphing. Okay, when we graph a line, we need to start by solving for y. So here we have 3x plus 2y equals 4. So we're going to solve for y to get the y's on one side. So we're going to move the x over to this side. Be negative 3x, negative 3x. Those cancel. We have 2y equals minus 3x plus 4. And now we're going to divide both sides by 2. So y equals minus 3 halves x plus 2. Okay, now in order to graph this, we need to find some convenient points. I'm going to make our handy dandy little chart here. I'm going to make my handy dandy little chart bigger. This will be easier for you to see, I think. Alright, I want 3 points to graph. Here are the x's, here are the y's. Let's start with x equals 0. If x equals 0, then y is going to equal 2. Okay, it looks like if I make x 2, then the half and the 2 will cancel. So let's try x equals 2. So the 2 and the half cancel, and we have negative 3 plus 2, which is minus 1. Okay, let's try that with negative 2. So now the 2's cancel, we have negative 1 times negative 3. So that would be positive 3 plus 2, so this would be 5. Okay, now we're going to graph this. Here's a graph. So our ordered pairs are 0 and 2, 2 and negative 1, and negative 2 and 5. So we'll start with, if the x is 0, then y is 2. If x is 2, then y is negative 1. So right there. is -2, then y equals 5. Okay, now we're going to use a straight edge. Yay! And we're going to graph this line. Remember, lines are infinite, so we put arrows on the end. And this is the graph of y equals -3/2 x plus 2. Okay? Let's try another one. Y minus x equals 0. We're going to solve for y. So y equals x. If y equals x, then if x equals 0, y equals 0. If x equals 1, y equals 1. If x equals -1, y equals -1. So our ordered pairs are 0 and 0, 1 and 1, and -1 and -1. Okay? So our first ordered pair was 0 and 0, and then 1 and 1, and -1 and -1. And this is the graph of y equals x. Okay, that's it. Try this at home. Let me know how it goes. I'll see you in class. Thanks.